Alrighty guys, let's start Unit 3. This is it for all the marbles. We are starting at the end of Chapter 5. The last section, 5-6, is Polynomial and Rational Inequalities. We have been studying polynomials and how they behave. Remember the bouncing, the scooting, the zeros, and all that good stuff in behavior. And we've been studying rationals. That was the vertical asymptotes and horizontal asymptotes and intercepts and all the curves and things. Okay? So if you can keep those in mind, that's what we're looking at. I'm going to do this in two different parts. First, I'm going to look at the polynomials, and then I'll do another video for the rationals. Okay? Inequalities means there's going to be less thans and greater thans, so we're going to do some solving that way. So we kind of have to remember two things at once when we do this. So I'm going to run through some polynomials, and then we might need to, at one of our meets, we might need to do some examples as soon as you guys get a little bit of a chance. I'm also going to have you doing a lot of this homework on Pearson because it's a little kinder gentler in some of these sections, and I think we'll be able to get away with that. Okay? So that'll be a little bit of a change there. Alright, the first thing I want to look at is just a polynomial, a graph of one. It's kind of nice. And looking at just the notation for this. Okay, this was notation that we were familiar with back in Chapter 3 and our polynomials from Chapter 5. So we're going to put some ideas together. Remember when it said f of x equals 0, it was the same thing as saying, where does y equal 0? F of x is just y. Well, y equals 0 on the x-axis. Here's where y equals 0. So when I'm saying where does it equal 0, I'm making a list. And so my list includes -5, +2, and +8. Okay? So just making a list of where it's equal to. When I say where is f of x greater than 0, now we've seen that notation before also, and remember that this means there's a whole interval of numbers where this occurs. Where the y is greater than 0 is where it is above the x-axis. So this part of it and this part of it are where it's greater than 0. So we write it in interval notation. So I'm going to start here at negative, gosh, that is really hard to read, -5. I don't want to include it because I don't want where it's equal to. I just want where it's greater than. So don't include the endpoint this time because it's not equal to. And it goes clear until 2, and then it's going to drop down below. I'm going to also have to include over here from 8 to infinity. All of these parts, all of those intervals, are where it is above the x-axis, where y is greater than 0. This one's asking where is y less than 0, f of x less than 0. Well, that's here. So I'm going to start here at negative infinity until it reaches -5. And then here, this interval also, so from 2 until 8. Okay, and that will be where it's less than 0. So our solutions are going to look like this. They're going to look like a list when it's equal to, but we're not doing equal to's. It's going to look like intervals where the answer is positive or it's negative. Okay? Alright, so here's the how-to. This is what's going on. I'm going to have something like this. I know that's really small. I don't know if I can make it bigger for you or not. I'm going to try, okay? This says x to the third plus 8x squared is less than 0. X to the third plus 8x squared is less than 0. What I want us to do is to pretend that this is equal to 0, and I want to solve that first. Did you notice on our graph that it's where it was equal to 0 where all of the changes occurred, where it became a change from negative to positive? And so that's what I want to find out first. Where is it equal to 0? So to find this, I'm going to factor first. I see a GCF, x squared. I'm going to take that out. That leaves me with an x plus 8. To solve this, I'm going to take x squared equals 0, and that gives me a 0 of 0. But did you notice something? Multiplicity. It has a multiplicity of 2. Do you remember that when it has a multiplicity of 2, it bounces? So I'm going to keep that in mind. I should see something that shows me that behavior. This one, x plus 8 equals 0, gives me that x equals negative 8. Okay? These are my zeros, and I'm going to place those zeros on a number line. Just those guys. Don't put any extra numbers on there. Only put your 2 zeros. Okay? This is your instructions. Gosh, it's not any better bigger, is it? These are your instructions so that you can look later at what you were supposed to be doing. So you find the zeros. Multiplicity behavior helps. And we're going to put them on a number line. Now what we're going to do is check our intervals for positives and negatives. I'm going to use the factored form to check for positives and negatives. And why? Because I can do it mental math. I swear it. You can do this mental math. Watch. I'm going to pick a number that would be over here less than negative 8. How about negative 9? Negative 9 over here. If I put negative 9 in here and I square it, I get a positive number. I'm just going to write that out. It's a positive number here. X squared, negative 9 squared is positive. It doesn't even matter what number it is. If I take negative 9 plus 8, I get negative 1, which is a negative number. Here's the magic. This is a positive number times a negative number. And when I take a positive times a negative, I get a negative number. Let's see how else that works. I'm going to pick something in between negative 8 and 0. Let's pick negative 2. It's a nice number. So I pick negative 2. I'm going to put it in here in this factored form. Negative 2 squared is a positive number. And negative 2 plus 8 is also a positive number. It does not matter what number it is. All I need to know is that a positive number times a positive number is a positive number. I'm going to pick another number greater than 0. I'm going to pick positive 2. If I put 2 in here and I square it, I get a positive number. If I take 2 plus 8, I get a positive number. And a positive times a positive is a positive. This is called your number line chart. Okay, they're going to ask for those on your final. Probably. They might refer to it a lot too. Okay, what's happening here is the polynomial is negative in this part. It comes up here and is positive, and when it gets to 0, it bounces off because multiplicity. So your polynomial looks like this. You already know that part. What I wanted was, here's my question, where is this polynomial less than 0? Where it's less than 0? Here. Where it's negative. So my solution is negative infinity to negative 8. Include it? No. No equal to. This is the solution. You should write these steps down, and we're going to try this again. You can pause me at any time. We're going to do that one more time. We're going to solve this inequality. I know that's hard to read. I'm going to have to figure out a good, bigger font size. This is x to the third plus 2x squared minus 3x is greater than or equal to 0. Okay, first I want to think about this being equal to 0, because I want to find my zeros. So I'm going to solve this thing. To solve it, I need to factor. Do you see a GCF? If I take out x, I have x squared plus 2x minus 3. This factors again. Grab a box, hit pause if you need to, and there it is. It's all factored up. This is what I'm going to use to do my checking. On your number line, we're going to put all of our zeros. This x equals 0 gives me 0. No multiplicity. This x plus 3 equals 0 gives me negative 3. And x minus 1 equals 0 gives me positive 1. These are my zeros. Put them all on the number line. Now we're going to check numbers in each of those 4 intervals. You just broke it into 4 pieces. I have to check 4 different numbers. I'm going to check them in my factored form because it's mental math. I swear it, watch this. If I put negative 4 in for this interval, negative 4 is negative. Negative 4 plus 3, negative. Negative 4 minus 1, another negative. Do you remember your even and odd rules from last semester? If I take a negative times a negative times a negative, I get a negative. So my polynomial is down here. Let's pick another number between negative 3 and 0. How about negative 1? If I put in negative 1 here, it's a negative. Negative 1 plus 3 is a positive number. Negative 1 minus 1 is a negative number. When I take a negative times a positive times a negative, my answer is positive. So my polynomial is above. It's going to come back down and hit 0. What's going to happen here? Let's check it out. I need a number between 0 and 1. 1/2 is a good number. Don't panic. This is nice. Watch. 1/2 is positive. 1/2 plus 3, positive. 1/2 minus 1, negative. A positive times a negative is a negative number. Oh, it went down here. Now what's going to happen when I get to 1? Let's check a number above 1. How about 2? 2 is a positive. 2 plus 3 is a positive. 2 minus 1 is a positive. A positive times a positive is a positive. Alright, that means this thing's going back up. So let's think about putting this all together. What is it that I'm looking for? Go back to the original. See how it says I want to know when the function is greater than or equal to 0? I want the positives. Do you see or equal to? I also want closed brackets. So I need the positives here and here. I'm going to write those in interval notation. Starting at negative 3 to 0, and also from 1 to infinity. This is your solution. Alright, if you need to go back and watch those again, that's why it's great that they're videos. We'll talk about it during one of our chats though, once you guys have had a chance to get started. Alright, we're going to do this with rationals in the next video. Carry on.